Hi, my name is Kutsia, and together with a team of bioengineering students, including Ahmad, Atarius, David, Dora, and Lonnie, and our research mentors Dr. Schnei and Dr. Zhang, our team was able to develop a working prototype of a spinal cannulation automated navigation robotic system, or SCANRobotic system for short. Currently, 80% of Americans will experience lower back pain at some point in their lifetime, and only 30 million Americans will actually seek medical care for a severe spine-related problem, such as scoliosis, for example, as you can see in the image to the right, showing an X-ray image of a patient with an abnormal curvature in their spine. Spinal fixation surgery is a surgical procedure that is performed to remedy these severe types of spinal abnormalities by inserting screws into the pedicle bones located within the vertebrae, as shown in the image to the right. The most important step within this procedure is the cannulation of a hole that is drilled by the surgeon using their tactile feedback into the pedicle and through the vertebral body, while a desired angle is maintained. This is currently done through the freehand technique, which involves the use of imaging modalities to enhance a surgeon's field of vision into the spine. The cannulation step is typically where most errors arise, since surgeons may drill into the pedicle at the incorrect angle, causing a breach into the spinal column. The freehand technique currently has an accuracy of 89%, which means it has an 11% error attributed specifically to spinal breaches, which may cause paralysis or even death in extreme cases. To address problems with current techniques, our team designed an automated system that safely navigates to the pedicle of interest using fluoroscopic images for registration, and from there performs accurate cannulation using a motorized drill attached to the robot's end effector, as shown in the image to the right. Our system is also aimed at reducing radiation exposure by limiting the amount of fluoroscopic images we take during the procedure. Furthermore, we aim to make our system highly accurate and cost-effective in comparison to other technologies currently on the market. We also aim to make our system user-friendly for surgeons, portable, and safe to use for surgeons during the surgical procedure.
This demonstration video conveys the steps to perform cannulation to a desired pedicle. The first step is to freeze the drill near the desired pedicle so that the drill tip is captured. A fluoroscopic image is then taken to properly register the drill tip and reference sphere in the same frame. Then the registered image is processed using our MATLAB program. The user follows the prompts to highlight the dimensions of the pedicle, specifically indicating the cannulation entry and endpoints, end plate, base and tip of the drill, as well as the left and right edges of the reference sphere for scaling. The program then provides joint angles to move the drill tip to the pedicle entry point and the trajectory for cannulation. These return values are inputted into the robot to navigate the drill to the correct position. The final step that follows is to drill 2 centimeters into the pedicle. To assess the performance of the SCANRobotic system in performing spinal cannulation, we implemented a grading system based on whether the trajectory that is drilled into the pedicle results in a breach in the spinal column. A grade 1 means that there is no breach into the spinal column and is considered a success. This is shown by the blue arrow in the image. As you can see, the path does not penetrate the column at all. The red arrow shows an example of a breach where the drilled path penetrates the column and is considered a failure. A grade 2 is a breach of less than 2 millimeters and has a lesser chance of causing harm such as nerve damage. Finally, a grade 3 is where the path goes 2 millimeters or greater into the column and can cause great harm. After grading each cannulation performed, we want to achieve a success rate of about 90% for this prototype. This is comparable to the freehand technique mentioned earlier in the presentation. We were able to test the SCANRobotic system on foam spine models at Inova. We performed the cannulation procedure on 8 pedicles and visualized the results using CT images, such as the ones you can see here. We inserted wires into the cannulated holes so that we could visibly see the degree of breach according to our grading system. They are shown as the white arrows in the CT images. 7 out of the 8 cannulations were performed successfully and received a grade 1 as they demonstrated no breach and can be seen in the image to the left. Only one cannulated hole resulted in a breach, as seen in the image on the right, and this received a grade 2, which means the wire breached less than 2 millimeters into the pedicle wall. So overall, from our testing, we received an 87.5% success rate. So throughout this presentation, you witnessed how our spinal cannulation automated navigation system works. We set out to originally address key problems in the spinal fixation procedure. We wanted to provide a safe and cost-effective system that could accurately navigate to the pedicle and perform cannulation. We were able to achieve an 87.5% cannulation success rate and reduce the amount of x-rays in the procedure to 2 per pedicle. So overall, we met our objective for our system to be safe, portable, and cost-efficient. Next, we plan to further improve the accuracy of our system by enhancing our software algorithms and performing further testing on more spine models, and then shifting towards cadaver testing when the time comes. Thank you.